So we're about ready to hook this amplifier up to some power now. I have the power supply at about 12.8 volts. I typically would run about 13.8. So you can run it in that range. I have it limited to about 2 amps. Now I want to make sure that we're not going to plug this in and this thing's just going to shoot off into space. So make sure you limit it down to about 2 amps. So we're going to hook this up now and make sure it doesn't run away. Alright, it's shot up and it went back down. It's settling. It's about 1.3 amps. Some amplifiers are going to require more turn-on current. Some amplifiers are not. Some like the 1507, you might have to limit the amperage around 3.5 amps for the turn-on spike, or else it just won't turn on. It'll just keep trying to turn on and turn on and turn on until you give it a little bit more current. Then it will fall back down into its normal idle range. But this one turned on within the 2 amp limit that I have, and it's running at about 1.3. And I don't feel anything getting hot, as I wouldn't expect, because I don't see any of the signs of a short or anything. So we're looking good here. So I guess now that we have it powered on and it's actually running, and we're drawing some current, so we have some hope that the power supply in this is good. Let's measure the rail. So where do we find the rail? Let's take a look in the microscope and take a look around here. You should find some beefy wires that will be grouped together or marked on the board. Right here, it might even be marked the voltages. We have a red, brown, and a black hidden down below there. And my guess is the black is going to be the common, and the red and the brown will be the rail voltage. So let's go to this view. I got my voltage, or my meter on DC voltage, and I'm going to try and sneak in there with this and get a probe on here and another probe on here. What do we get? I'm not making a good connection, I don't think. Alright, minus 21 volts. Alright, that's okay. That's better than nothing. And it looks like by the board stamp they had 23.5. So let's go to the red. We should get positive 20 something. Yep, and we do. So we have plus and minus swing on the switching supply for the amplifier. So one can assume that the power supply is functioning at this point, and we're feeding power into the amplifier correctly. So now, obviously, we removed those 2 parts. One had a short on it, so we might have hope that these other channels are functioning, and we just have to troubleshoot one channel of this amplifier. This is the problem with sometimes when you're diagnosing somebody else's work, is you don't know where they left off, you don't know what they changed, you don't know what they did, because that red wire that was here that I unsoldered from a transistor was not stock wire. That seems like a patch that maybe because of one of those pads lifted that somebody added on after. That's entirely possible. So now the thing to do is to inject in a signal in on the preins and see if we get any output. I have basically put all the gain controls about halfway up. You don't want them all the way up. You don't want them all the way down. I run them, maybe 25 to 50%, somewhere in that range for a testing purpose. So yeah, I guess that's it. We'll have to try and put a signal into this, see what we get. So I'm going to plug this in. And we're going to look for a signal on the channels with the oscilloscope. I think this is an active channel right here on that wire there coming in, and yeah, we're getting some craziness going on here. These are in the channels that I thought were possibly good, and there's something evil going on here. I don't know if there's something in the preamp stage that's causing this or after that integrated amplifier there. but this is not looking good so far. Let's go to another channel. Nothing. Oh, there's that odd signals again. So something in common with all these amplifiers is not proper. We're going to unplug it and just feel around for anything that might be heating up excessively. Ooh, those two transistors there feel quite warm. Might be normal. Oh, I do see a little burn mark on the side of this resistor here. I wonder if this transistor has a short on it, and we're killing half of the power supply in the amp board section. So let's investigate that. Alright, so I'm on the underside of the circuit board where those transistors are, and it appears to be a place where heat was definitely collecting. It looks a little heat scorched or discolored in a way that might have been from possibly a shorted component. That's one transistor, and this is the other one. Let's check the front. I'm going to put it on diode check and we'll see what we find. Without a schematic, we're totally just shooting in the dark here. We don't know what's going on. We're just trying to find the obvious stuff. Okay, we got a junction there. We got 0.06 volts there. That doesn't seem right, but we could be reading across a coil. Yeah, 0.8, 0.4. Let's go up to the other one here, and 0.4, 0.4, and we got that weird 0.06. Those are quite low numbers that then I would like to see across a junction. 626 one way, 627, so that is exactly the same reading both ways. Either it's a problem with the transistor itself, or there's a component in the circuit that is going to be symmetrical across the reading from one probe to the other. Yeah, 630 and 630. That might be okay. Let's check those resistors. Got those big power resistors. And we got 22 ohm there. And what do we get on this one? 22 ohm now. So even though it's a little scorched, or it appeared to have a scorch, it could just totally just be somebody touched it with a soldering iron or something, or it could be some flux buildup. This could be completely normal, but the only way you're really going to tell is if you pull these transistors out and check them to make sure. It'll give you a peace of mind. It may take you an extra 10 minutes. It's most likely not the problem, but it's a good thing to check if you see anything weird like that. So let's flip the board back over for a second and see if there's anything that might be possibly reading that odd measurement. What are these parts? They're tip 41s and probably tip 40. What's the other one? I can't read it. Yeah, they might just be standard Darlingtons or something, or PNP or NPN standard transistor. So let's see, where are we here? Yeah, these two here. We got a couple diodes that we can check here. Again, might be pointless in circuit, but it's worth to see if there's a short. And we have 0.4 one way, and And yeah, see, we're a cap is dumping out right now. 0.6, 0.7. That's probably going to creep all the way up. So we might have just a capacitor that was kind of screwing with us a bit. 0.7. Yeah, seems to be doing the same exact thing. So, I mean, the least I'm going to do is pull those two transistors out and check them. But something in common is wrong with a lot of these channels, it appears, because I am throwing in a signal to the input board here. This multiple input board. I have about 4 channels plugged into it right now, and I'm not seeing any signal on the output of any of these amplifiers. So I guess we're gonna have to go a few steps back and try and see if we can pull signals off of the input to the amplifiers. And without a schematic, we're going to have to probe around and find where that would be. On the UPC1342V, this is the 50 to 110 watt power amplifier driver. This is that device that we were looking at with all those leads on it. And if we go through here and look through blah blah, you can pretty much get the voltages that the chip should run at. You can measure voltage pins, and like I said, you will get sample schematics. And here's one sample. It doesn't look very, it could possibly be very similar, because we saw two big resistors on the output side that looked very similar to that. And maybe this is more like it. We have a signal coming in over here through a cap, and it looks like we can, on this particular depiction, you can actually ground the input to the amplifier, or you can switch it to a signal input. So it looks like pin 4 is our input of that device. So one would think that our signal should look good from signal to pin 4. And if you look here, you'll see Q1 and Q2. These, I believe, are those two output transistors that we have, the two, one N part and one P part. Actually, these are two N parts. Do they have another version here? No, they're both ends. Well, that is very interesting. Ah, here we go. This is probably more like it. Basically the same thing. See all the different configurations this chip can be configured. There is a maybe a half a dozen or a dozen different schematics you can browse through. Just try and find the one that closely matches your circuit. Not all documentation is going to do this, but we got lucky on this one that actually had these little samples in here. But it looks like we have an N part and a P part push-pull type thing, two resistors, a couple 10 ohms. This is probably going to be the closest thing in this data sheet that is going to resemble what we have. And there's the part itself and all the pin-out configurations. Pin 4 is indeed the input. So we can put our scope on the power supply ground and probe pin 4 of this IC, and we should have our normal sine wave. So let's do that and see what happens. Alright, so plug in the supply. We're drawing about 1.35 amps. And we're going to see on pin 4 what we have for signals. Let's start with the very first one. Now remember, I only have 4 inputs active right now, and that one does not resemble a sine wave. Let's try another one. We got that one here. That one's not looking too good. That one's not looking good. That one's not looking good. That one's not looking good. And that one. So I'm not exactly sure what's going on at this point. I would have expected to have seen a signal there that would have been okay. That is the stage that is before the finals. This kind of is the pre-driver. So, it's really getting in depth now. I think we got some control voltage issue maybe. So we're going to have to check the voltage for all these devices and make sure that we have the plus and minus power supply rails available for the chip to utilize. And if we do not, then we have something in between this board and the power supply board, because the power supply board appears to be putting out the correct voltages of plus and minus 20 something volts. And if we don't have it here, then we're probably just going to be seeing a lot more of this garbage signals on the oscilloscope. So yeah, we'll just have to keep digging. Alright, so we're back here with the schematic again, and we're going to see if we can find out what the power supply rails are. And it appears that we have on pin 1 and 2, that is the positive rail, and on 9 and 10 is the negative rail. So if we go back to the microscope cam here, we should be able to say that 1 and 10 are the plus and minus rails. So that would be pin 1 would be right here, and 10 would be right here. And we're going to plug this in. She has turned on. What do we got on pin 1? We have plus 23 volts as we'd expect. And on pin 10 we have 5 volts. That should be 20 something. Let's go to the part next to it and see what we have here. Pin 1 plus 23, and on 10 we have minus 23. That's actually correct. So I'm not sure why we would have missing voltage on that. I don't know if something internal on this is dragging it down. We're going to have to try and trace that out. But this is the bad channel that we have the transistors removed. So this could be partially the reason why we're having a lot of issues with this channel. There's a lot of components seem to be failed in this channel. But that does not explain why I'm not getting correct signals in and out from the rest of the amplifier. I'm not entirely sure about that yet. So I think what I'm going to do now is trying to verify that these power rails aren't directly connected to each other, and if they are, if there's a break in between, or if this component is dragging something down through a resistor or something, because that is not right. Yeah, so I'm going to do a little more digging, and I will come back and let you know if I find anything. Alright, so what I'm going to do is measure between two good devices here and see if they share the common rail, which they should. So we got that one here, and we got that, and we go to 10 and 10. This should be this one and this one, and it's there. Now if we go here to this is the one we are missing, one of the rail voltages. Let's go here to the other one. Is indeed there on that one, and from here to where are we? Here we have a 10 to 10, and we heard it for a second, but it's gone. go back to the other amp here. Yeah, so something between these two are not, or between this and the rail, it's not connected properly. I don't know why. I don't know if it's because this might be a broken tray somewhere. This device has been pulled out before, so something may have gotten torn up. That's what I'm guessing here. So I'm gonna have to pull that device and look underneath it, see if there's anything obvious. Could be a bad via. And on the other side of this amplifier board, if you recall, let's go to the, see if I can find it here. This red wire, it went to the output. It looked like somebody had just put it here. Here we go. This was connected to one of the pins of the output transistors, which was right here, was connected. And I noticed that on the other channels that wire does not exist, so that was a scab from somebody else's work. So they definitely had noticed that some traces were not connected properly and were missing, and that is been confirmed on this. Get a meter. If we go to, looks like that's the second pin over. If we go from here to where it was connected, we don't get anything. And if we go from the number 2 on this one to the pin of the output, it should ring out. It does. So there is a lot of connection issues in this circuit on this channel. So I believe I'm going to pull this up and see if I can correct a lot of those issues before I move any further. I'm going to leave that amplifier IC out until I can troubleshoot the signals issue for the rest of the amp. I'm still getting very odd inputs, and I'm not exactly sure if the preamp circuit is firing up, so that'd probably be the next area that I'm going to start probing around in, because if I can't get a signal into these amplifier chips, they're not going to produce an output. So we got to keep working our way back here a little bit. Alright, so I have removed the component, the integrated amplifier, from the circuit, trying to find out why I could not get my voltage rail on this 10th pin, and I have traced it all the way back to the output vias. There was a couple vias that are damaged, that aren't passing the continuity between one side or the other of the board, and that could be probably why these outputs were suffering from a short. Yeah, so this channel definitely needs some help. It needs some work. I don't know if we're not going to be able to repair the vias, but we may be able to reroute the circuits a little bit to their appropriate place with some wiring. So we're going to have to compare this to the next channel once we get this amplifier up and running. My other bigger concern right now is trying to get these other possible functioning amplifier sections functioning, and we're not seeing that input signal on pin 4 of the amplifier IC. So I think we're going to have to start probing a little bit further back in the preamp section. I'm not entirely sure where to start yet. I really do wish I had some schematics or service manuals for this stuff, because that is about as far as I can go with my print that I have online.